Hi guys, so today I'm going to share with you a very interesting project that I made, and it's using LangChain, and I've made this on Python, PyCharm specifically. So let's look at what my program does. So when we run it, and this is basically a AI research agent that I've made using LangChain, and what it does is basically you ask it a particular question and it look at different types of sources, and it basically extract the exact answer that you're looking for. And this is the tutorial that I'm making today for. And once we look at how the program actually works, we are going to look at the specifics of it. We are going to see different types of Python files that we'll create for the functions it will be doing, and we'll be adding some libraries and requirements. We'll connect it with database. So let's look at what this function does. For example, it asked me to enter my research question. So let's ask it what's the capital of America? America. So it will take some time to process it. Yeah. So as you can see, it's given me the answer, which is the capital of the United States, which is Washington, D.C. And it has given me the sources that it has accessed to find out the particular answer, and then it has saved it to DB, which is the database. So firstly, we are going to see the architecture diagram for this particular project, which will give us a better overview of what we are going to do. Okay, so guys, this is what my architecture diagram looks like that I've created with draw.io, and I know it's a little bit complex, but I'll just skim over it and tell you the details that you should be knowing. So firstly, let's start with the top. This is actually our user input, what we want to ask our agent. The user input is simply what the user types. It could be like a question, a command, or you can just call it a prompt. This input goes into the router. It's also known as intent classifier. The component job is basically to decide if this is a simple question, or does it require tools, or does it require any memory or database access, etc. etc. So next over here we have the at the center of the diagram is the LangChain agent, or you can call it the orchestrator. This is basically the brain of our system, and inside it you can see it's a decision loop, which is often called thought, action, observation, and then repeat. Thought is basically the agent reasons about what to do next, and action is basically it decides to call a tool, database, or API. Then comes the observation, it looks at the results, what we've got, and then it repeats this loop until it has enough information. So this is what makes the agent feel intelligent instead of just reactive. Then next we have the memory database and the context of it. So this is basically where our data will be stored, like the data that is coming from our input, and the conversation history, the vector database that will be created, the SQL databases. This basically allows the AI to remember previous messages, retrieve relevant documents, and maintain long-term context. Next, we have the API tools. The API, basically the internal APIs and search engine, business databases. These tools return real-world data, not just text predictions. Then over here we have the large language model. The agent basically communicates with the large language model or the LLM that we use. LLM, as you must have known, understand the natural language, helps with the reasoning, and generates text responses. And it just answers directly, and it works. Sometimes it works with other tools to like refine the response. As you can see, these are all connected with each other, and once it reacts with the LLM and it creates the final answer, where the final answer module formats the output. It translates if needed and ensures safety and clarity. So all of this is, if I want to tell you in very simple words, the router basically decides the path, the agent thinks and plans everything. The tools and databases basically provide us with real data and its storage. The LLM basically generates the language, and the response system basically delivers a clear answer over here. So this is the quick overview of our architecture diagram. Now we will just move on to the next part, which is basically our code, and we'll just write the code together. Okay, so guys, as you can see, this we are on our PyCharm, uh, and all you have to do is just go to your search bar, and you have to type PyCharm, and then you can just search for your particular version that you want to use. And once the application starts, all we have to do is go to this files and just create your new project. You can give it your name, whatever you want to do or you want to give. Over here, I have given it the name of AI Research Agent. You have to choose your environment. You have to choose your version of Python that you want to use. Over here, I'm using Python 3.13, and you just have to press create. So I've already created a project for myself. Now we'll just start adding files to it. Sorry. Yeah. So let's start creating our project next. So for firstly, what we want to do is we want to create multiple Python files. So firstly, let us first start with what we want to achieve first. What we want to do is basically so firstly what we want to do is we want to import different libraries in order to make our project. So what we are going to do is we will go to yeah, so firstly what we want to do is we want to create multiple Python files. We want to import the libraries. We want to connect the API for example, in our case, I'm using Hugging Face. So we'll create that particular API from Hugging Face website, and we will create its token. Then we will connect it with our own project. So firstly, let us create multiple Python files here. I go to Python files. I will start with my agent that I want to create. Then I will add my Python file next, which is named as db because we have to store it in our database. Then next, what we want to do is we want to create another file, which is basically the main file, which we will be using to, which will be using finally to execute our code. Then next, what we want to do is we want to create the requirement text file. Uh, File requirements .txt file. So the requirement file is empty. Yeah, we will just deal with it later. So we have our agent, we have our database, we have our main file. What else do we require? We will require, for example, we will need to convert it into vector store, vector database. So we have to create the script file, like we have to convert it into a format that we will be able to understand. For example, I have decided to write what is the capital of America. So the LLM will search all the web pages and it will try to catch all the information it has. Then it will try to scrape the data and it will show us in a particular sense that we can understand and fully see. So we have to create a scrape file. We have to still create the LLM file which we will be using. Then we have to like search the we have to create a search Python file which we will be using it for searching it on the web pages. So let's start with all the utilities we require. So I'll just come over here, new. So I want to just create it into a directory, ut, we will call it utils. I'm just keeping it separate so that we know when the program is trying to connect it with internet and search it on different web pages. So I'll just add all of the different utilities in this particular folder. So I'll create a Python file, which is our LLM file. Sorry. Next, I'll create a scraping file. Is scrape. Okay, scrape file is also there now. We have to create now the search file. Okay, search file is also there. Actually, it's not gonna come here. Let's just leave it there. I want to create a search file here. Search file. Then I want to create the vector store. Vector store is also created. Next, we also require another file which I'll explain later. Basically, it will hold our API and the URL that we will require to connect with Hugging Face. So I'll just create it. This is the standard that is used. What else do we require? Do we require anything else? Uh, I think that should be it. Maybe I'm forgetting something. Oh yeah, there's one more file that we need to add, which is basically if we want to use Streamlit. Streamlit is basically it shows us our app in a more it gives us the program in a better UI. So let us create another Streamlit app. Streamlit score app. Okay, so we have created all the files that we required. I think we have accomplished what we wanted to. Yes. So next we will start just our coding then, which is the part we needed to do first. Yeah. Actually, rather than using this, we just create another env file. .env file. I'll tell you later why I've done this, but let us start basically working on our project. So where should we start with? Firstly, I want to do is I want to get the prompt for our function. So before that, let us write our libraries. So libraries that I'll be using are basically so guys, the first library that I want to use is request. I'll just write the code first, then I'll explain to you guys what I've done. Request next library sentence transformers and python dot env file library, sorry, then DuckDuckGo search beautiful soup for Streamlit Mesh SEO. So these are the libraries that we've imported, and next what we want to do is I'll just explain it briefly. So this library I've imported because we'll be making API requests and HTTP requests. Uh, it is basically used to call APIs or download web content, and this particular sentence transformer, it's basically built on top of Hugging Face transformers, and it converts sentences or documents into vector embeddings, and it's basically commonly used for text similarity, clustering, reg, retrieval, augmented generation. And nextly, the python.env file, library, it basically loads your environment variable. And this one, Facebook AI similarity search, basically it's commonly used for semantic search, recommendation systems, and vector databases. This is also used for searches. It performs web searches using DuckDuckGo without any official API keys. And it's also very useful for web searches and fetching certain information. Next, we are using IO HTTP, and it's used when you need to make many HTTP requests concurrently. And basically, it's faster than requests for large scale or parallel network tasks. Uh, and this is your favorite library for data science people. Beautiful soup for, and it's basically used for parsing HTML and XML files, and it's used for web scraping. It extracts text, tables, links, whatever from your web pages. And this specific library that this one that I created, Streamlit, it basically is a framework for building interactive web apps, and it's commonly used for dashboards, ML demos, and internal tools. So we can use this because we don't want to like make a separate front end. Uh, yeah. So next is this particular library, which is basically needed when running async code in Jupyter Notes or Streamlit. Yeah. So this is just a brief overview of the libraries that we will be using. Yeah. Okay, so let us now try to install our libraries. So we go to terminal and we write install, sorry, pip install requirements.txt. Now we just have to wait for the libraries to be installed. Okay guys, so I went ahead and given it the time it needed to install all the required libraries. And next, what we are going to do is, as you can see here, all of the libraries are installed. Now let's just dive into the coding part. So just ignore this requirement. Let's start first by writing the agent Python code. So we'll just write it together. Port syncyo import from utils search import search web, and then we will just from start scrape import scrape URL. Yeah, it looks good so far. Next, we will add utils dot lm, and I will import the generate answer. Okay, so this is the name of the agent we will be using. Max underscore search users equal to 6. Retrieve. For so next we will just write the results search underscore web query. Yeah, results. In this particular function, you are just doing the search equal to sorry guys, I'm using German laptop, so let me change it to US. Sorry. My God. Yeah, found it. We have to use square brackets, R square brackets again, then URL for RN results. You have to async the script that we'll be writing later. As session where we write tasks, script URL session view. These are the parameters that we've given. And for u and URLs, pages equal to await is q dot gather tasks. For p in pages, p and p dot strip just a moment. P and p strip. Yeah. So it's actually p. And this looks good so far. Next, we have to ignore text, then it will return. Let's return the answer, which is no useful page found. Page is found. And the sources will be just empty. Sorry, this is a dictionary. Okay, so next will be index. Uh, yeah, it will be index space text. Retrieve We are now just retrieving the relevant chunks. Query section index query text index, and finally we have k is equal to k retrieve. Yeah, context equals to and and dot join with retrieve. Yeah. And to give the prompt, which is you are a concise factual agent, research assistant, then and you have to use only the context below. Use the context below to answer. Dot. This is just changing the lines. Question. Context. Yeah, this looks good. Write a clear answer. It includes short sources. Sorry, short sources. List the original URLs. And what we want to do is and be explicit about the uncertainty. Yeah, This looks good so far. I think so. Hmm, Yep, looks good. Now what we want to do is we want to generate the answer via the API. We haven't connected the API yet, but we will do it later. Let's just write the answer that it will generate it generate the answer about the prompt and return what? The dictionary. The answer this part basically, but should be the answers. I think I made a mistake over here because I forget to add the square brackets. It should be empty, and this one should be the URLs. Yep, everything looks good so far. Uh, Let me just check it one more time. Mm, Yep, everything looks good so far. So let me just explain you the code, what it's doing now. Okay guys, so let me quickly explain you the code. So these are just the requirements that we will be getting from the libraries. And we have basically defined a research agent, which basically takes a query, sorry, which basically takes a query and it tries to search the web, read its relevant pages, and pick the most useful information. And it basically generates a clear AI written answer based on that information. So over here, as you can see, the result part, this basically uses a search web and it finds the web pages related to the question, and it also collects the URL of those pages. Next, over here we have what we call client session, which basically uses async code to fetch multiple web pages at the same time, and the script URL basically downloads and extracts text from each pages. And this part basically it keeps only the useful text and it filters out the empty or failed pages, and it stores valid page content in text. And if nothing useful is found here, then it just says no useful page found, and the dictionary just becomes uh, we'll just get an empty list. Yeah. Then next over here we have this part which basically converts the collected text into a vector index, and it allows semantic searching instead of keyword matching. And this part basically it retrieves the most relevant passages, finds the top k text chunks most related to the question from the chunks we have created, and these will be used for our answers. And this is the prompt which you can also modify for yourself, but we are just using a factual research agent, so it won't rely much on the emotions and give us just the facts. And then we just return the results, the AI generated answer, and the list of URLs that we were supposed to get. Yeah. So basically, what it does, it searches the web, reads multiple pages quickly, finds the most relevant information, uses AI, and finds the source based on them. So next, we will just go to. Okay, guys. So what we want to do next is we want to search the web pages using DuckDuckGo. So I will just go ahead and write the code for that. Okay, so search. Yeah, so we will just write the import library from DDGS. You want to import DDGS. Then we define basically search the web. Similarly, like the previous one that we did, maximum results equal to 6. Results, results equals to with GS as DDGS. Sorry, for R in DDGS dot text query max results URL equals to R dot get H reference or R dot get, sorry, R dot get URL. Oops. Title is equals to R dot get title, or keep it empty as it is. And if URL and URL dot start switch HTTP, then result should be appended in the URL, and the title should be appended. And if the length results should be length of the results is how to get greater than, I think this one is it. Yeah, greater than equal to the maximum results. Then we want it to break. Otherwise, return the results. Yeah, this should be length. Yep, this also looks good. Now I will just explain the code. So guys, uh, don't need to explain this. So we are just generating a search function, search web function, and we want it to look up and return a list of relevant web pages. We have introduced here results list, which is empty, and this basically imports DDGS. It's basically a Python library for searching DuckDuckGo without tracking. And this part basically opens our DuckDuckGo search session, and it automatically closes when it's done. This part basically sends the query to DuckDuckGo and iterates over each search result that is returned. This part basically extracts the useful information. It tries to get the uh, page URL and the page title, and it basically handles different response format very safely. Uh, this part basically it keeps only real web URLs and it ignores empty results or invalid links. And this part basically limits the number of results and it stores the title and URL and stops when the desired number of results are reached. And this basically is what we return a list of dictionaries. Once we have found the relevant pages and the content in it. So in short, basically this function searches DuckDuckGo for a query, it collects clean valid web links, and it returns a structured list of results for our research agent. So that's about it for we are done with search part, we are done with the agent part. So now let's go to script. Okay, so guys, let us start coding the script file, Python file. So from HTTP, actually we have already done that. Just have to import it now. AIO HTTP and from beautiful soup for you want to import simply beautiful soup async def script score URL session score URL and the maximum number of characters should be equal to, for example, 20,000. Next, we want to try accept handling. So we try headers equals to user agent, sorry, user agent vanilla. You want to use five point oh research agent. What's the problem? Oh, so sync with session.url get URL headers headers timeout 0 timeout after 10 as response. Note the text to await soup, beautiful soup text. Basically, this is HTML parser. Let's submit. 40 in soup. Script style, navigate, nav, footer, header, SVG, and no script. Yeah, decompose, cleaned, join, and dot strip for line in soup.get text. You have a separator over here, which is basically this part, and we split the lines. If line dot strip, looks good. Now we just return the cleaned until maximum characters, except exception, return empty. Sorry, I missed that. Okay, so this looks good too now. Let me just explain what I've done over here. Okay guys, so let me just explain what we have done over here. So yeah, so this is the function that we have created, and it basically fetches web page from URL, and it removes unnecessary HTML elements and extracts readable text, and it returns shortened and clean version of the pages. We have basically a session using this particular library, which is efficient for reuse, and we have the URL, the web page, which is basically the web page to script, and the maximum characters. This is we are telling the application that maximum number of characters to return, so that it prevents the huge text that we will get. So this is basically limit that we are applying. And then over here we are using try and accept, and we are using a header which basically pretends to be a browser so that it helps us avoid being blocked by some websites. And this part basically it makes an HTTP GET request and it waits for up to 10 seconds and it reads the page's HTML as text. So this is basically beautiful soup. We convert the raw HTML into a structured that's easy to work with. People working in data science almost already know this. And finally, this part, basically what it does, it removes the navigation bar, the header, the footer, the icons and hidden content, JavaScript, CSS. It basically keeps only the meaningful page text which we require. And over here, basically we clean the remaining text. We extract all the visible text, remove the empty lines, trims extra white spaces, joined everything into a clean text block. And this basically returns only the first max characters so that it prevents token overload. And this basically is our error handling, which basically if anything goes wrong, the function just fails quietly and remains an empty string instead of crashing. Yeah, so looks good now. We proceed to write our DB Python. Okay guys, so I went ahead and written all the code that was required. I will just simply explain it to you to save your time. And basically what we are doing is uh, the database is basically stored in a local file called researchhistory.db, which is the name that we have provided. Next, over here, we are basically creating the database in table. This basically connects to the SQLite database and it creates a table called research and it checks if it doesn't already exist already. We have the unique ID and the query, the answer, and the list of sources created at, which is basically the timestamp of when the research was done. And this line basically ensures the table actually exists. And then we save the research over here, the result that we're getting. It basically stores a completed research session in the database and it converts the list of source URLs into a single string and it saves the current UTC time as an ISO formatted timestamp. And next basically is the this function get history, which fetches the most recent search entries and it returns up to the limit, which is basically 50, and orders results so the newest entries appear first. So this is the returned what the rows contains. Then over here, just we ensure that the database and table are ready as soon as the application starts and prevents error from missing tables. So in just simple words, we basically just create a local database. We were supposed to use the FAISS, but the tutorial will get very long then. So I'm just creating a local database and we save the research question answers, sources, and timestamps, and just allows us to view recent research history. So yeah, this is about what the database is. Now we just have to deal with this part. So let's go ahead and do it. Okay guys, so next what we have to do is we just have to go to Hugging Face and you have to just generate your own API. As you can see, I've entered my own API and the model that I'm using. I've made some changes to my API so others won't be able to use it. Uh, yeah, so this is just a dummy API that I'm using, but to run the code, I'll just fix it and I'll just show it when I'm going to run the code. So this is also done. If you want to know how to connect the API, we can do it later in another video. So we just go ahead and deal with the LLM Python file and write the code. So let's go ahead and do it. Uh, Sorry, just second. This looks good. Yep. So let's write our. I'll just move fast. Import requests from .env. We import load.env file. API key and the model. Stream model and this particular model API URL. Give it the API URL which you can find in Hugging Face. HTTPS uh, router dot Hugging Face one chat completion. Headers authorization F bearer of the API key. API key. Content type application JSON. Next, we have to define the generate function to generate the answer. the prompt with maximum tokens limit 300. And the temperature to be, for example, let's say 0.2, and the top P we say to be, for example, 0.9. Now we want to dump the payload too, so the payload should be dictionary, which is a model. Choose this, the model, the message, which is again a library, dictionary. Role is the user, and the content is the prompt. The maximum tokens and the temperature and top P. Yeah, this looks good. Response request dot post request the API URL that we've provided, header payload JSON. Let's add timeout to 20 seconds. If response 200 want to return F API error, which is the response text. This goes here. Now you want to try data JSON. We return F API data choices. messages and the content. Except exception is E, return F, exception, parsing response, E, and the raw response text. Yeah, this should be it. Now we quickly jump onto our main Python function and we start writing it. So from syncyo from agent, we import research agent, and from DP we are importing the save research. And if the name main, we say that q is equals to, for example, input a prompt, which is enter your research project question, search question, and strip it. If not q, then we just print that there is no question asked. So just exit 0. Don't worry guys, I'll explain the LLM and main function together. I'm doing this just to save your time. Res equals to syncyo dot run search agent q. Print this one. Yeah, we say answer. Then we print sorry answer. Then we just write print the source for s in print s. Just save research, queue, answer, and the source. And we just print that save to DB. Okay guys, this looks good. Now let me try exporting the LLM first, the LLM Python file. Then we can move ahead to the main Python file. Okay guys, so let's start with the explanation. So this is just the import that we have done. We are accessing the operating system environment and we're sending the request, HTTP request to Hugging Face API. We are importing this basically loads variable from the environment file into the environment .env file to the environment, and this basically loads the environment variable, and this is just our API key which the program is reading, and it's used for authentication with Hugging Face. And this is the model that we are using. We could also have set it to default. Uh, this is the API URL that we are using, which is basically router Hugging Face. Next, we are using the HTTP headers, and this is basically the content type. It's sending the JSON payload. Next, we have the generate answer function. So this function basically sends a user prompt to the model and it returns the model's text response. And we have given it the parameter of prompt, which is the user input text. We are uh, specifying the maximum tokens, maximum number of the model responses. Temperature is basically nothing, just randomness. And top P is basically the nucleus sampling. So the model is basically which LLM to use, and the messages is basically the conversation history. Uh, and similarly, this particular part, it's basically sending the post request to Hugging Face, and we have set a time offered of 120, which prevents hanging forever, and it uses JSON payload. Uh, Next, we have this one, which basically, if this basically is handling of API errors, and if Hugging Face returns an error 401, 403, 500, etc. So the raw error message is received, and this is nothing but we are extracting the assistant's text over here, and the accept is basically telling us to handle the fallback error, which basically catches JSON parsing errors or unexpected response formats, and it returns both the exception and API output for debugging. Yeah, so in simpler words, if we talk about the main function of this code, this basically is loading your Hugging Face API key securely. It's calling the Llama style chat model, It's sending the prompt and it returns the model's answer as plain text and it handles API and parsing errors. Yeah, so this is the general explanation for LLM Python. And so next we want to talk about the main function that we've written. So similarly, we have imported the particular libraries and we are getting the input over here and we are telling it that the input validation is occurring over here. So it stops execution if the user enters nothing. It prevents unnecessary API calls or errors. And this particular part basically it runs the async research agent. It creates an event loop and return the coroutine and returns the result synchronize the results. Then next over here we basically have the answer, which is the result, and the sources that we are printing. Yeah, so that's about it for this particular part. So guys, if I have went ahead and I've already added my Streamlit app code, which is basically the to view the our agent in the front end without having to do most of the work. So let me just explain what we are doing over here. So we are importing Streamlit and we are setting up the page agents page setup, which is sets the browser title page layout, displays the main app title, and it simply over here simple usage instruction for user. And over here the query, this one for example, I'm saying how do solar flares affect satellites. So this is the text box for the research question, which I've pre-filled with the example. Let me update that to, for example, what's the capital of America? Yeah. So next we have, yeah, this one, it looks correct. So the next are slider, which are basically how many web page results to fetch and how many document chunks to retrieve for answers. So we have defined that over here. These parameters basically let the user control the depth and the speed. We are creating two columns and we are creating buttons. And over here we are running the agent. So for example, over here, this shows a loading spinner while searching the web and fetching the pages and running the LLM interface inferences. And these are just the display results and the display of the sources. And over here, we are just saving it to our database. We are this sidebar, we are creating the sidebar that displays the last 20 entries. And basically, this particular code, it displays each history entry, for example, the record ID, the question, the answer, the stored source, the timestamp at which it is done. Then we have the expander that we have used, which basically if we click and it expands the history cards, which basically keeps our user interface very clean. This one basically shows the first 800 characters and it prevents very huge, very large text blocks. This is again just to display the source. Okay, so guys, we are only left with one more Python file, which is the vector store Python file. So I went ahead and written the code for it, and I'll just explain what it's doing. So we are just using the embedding model name, and uh, this basically loads a pre-trained sequence embedding model, and this part basically it's a high quality general purpose embedding model. You can also read about it by going to this, that it's a sentence transformer. This model is loaded once at import time. Next, we have the embedded text. It basically converts a list of text into numerical vectors. This is because computer understands the numeric values better. And now over here, since we at the time we are using FAISS, which requires the float 32 vectors. So we have basically defined it over here. And next, basically we build it, the index. This what it does is basically it embeds all the text, creates a similarity index, and add the vectors to the index. And next, it basically returns the index objects and the stored vectors. Lastly, the query index, which basically embeds the query text and it searches the FISS index, returns the top k most similar text, and the final output is basically a list of the most relevant text chunks. So this is what we are doing is just embedding it. So in small summary, it basically embeds text using a strong transformer model. It stores vectors in FISS. It retrieves semantically similar text. It's basically the core building block of semantic search and reg systems. Yeah, so everything looks set. Now we can go ahead and run our model. Hopefully it should work. It will take some time. Yeah. So enter your research question. What's the capital of America? Okay, it looks like there's some error. Uh, Let me go and fix it. Okay. Okay, so guys, I went ahead and fixed the mistake, which was a syntax error. So let's try running our program again. Right now, we are just using the compiler from our PyCharm. Let's see if it works over here. Then we'll try it with Streamlit. Okay, so what's the capital of America? America. Okay, now it's working. So the capital is Washington DC. This information is explicitly stated in the context, the nation's capital city of Washington DC. So these are the sources that it filtered, and these are its sources. Okay, nice. It seems like it's working. Uh, okay, so further. Okay, so let's now try running our Streamlit. So Streamlit run. We basically have to provide it the path. See users. This is basically the place where the file is stored. By Charm projects AI research agent uh, Streamlit app.py. Okay. This is by not. Oh, did one more mistake. This is by app.python. It should work now. Let me just copy paste this. Let me try it again. Okay, so it has finally worked, and I'll just go to local URL. Okay, so this is working now. We've provided these are the like the questions that we asked it earlier. Like for example, we asked it Mexico, run agent. Okay, there's error. The token is longer than, yeah, so it's taking us longer than the required time. Let's just ask it America. But you can see we got the sources. Yeah, you can see this first. This is working. Washington DC, the sources, the filtered sources, the total sources, and it's storing the searches. So yeah, yeah. So this is it for today with the tutorial, and I will see you next time with the next project. Please do like and share so I can keep making tutorials for such project. This was my first tutorial, so I'll just learn on the way on how to move forward and how to make it more meaningful. Thanks for having me today and see you.